My name is Higgs and this is my friend Boson. Welcome to the Higgs world.
Thanks for the introduction, Higgs. In this presentation, our goal is to offer you a quick summary of the research and conclusions. We follow inquiry-based learning model where students take lead in learning.
First, they get a quick review of the research via the videos. Second, they review the paper to learn and understand key concepts. Finally, they can follow up with further research on their own to dig deeper. In the end, students would have learned something new, latest and relevant. Isn't that wonderful, Boson?
Great point, Higgs. Please follow the links to review the research in further details. We want to thank all the authors and publishers for making this research public, thereby advancing science and innovation. Please like, share and subscribe.
Today, we are going to review a paper titled, Road Salt Damage to Historical Milestones Indicates Adaptation of Winter Roads to Future Climate Change May Damage Arctic Cultural Heritage. There is no doubt that anthropogenic global warming is accelerating damage to cultural heritage. Climate change affects transport infrastructure, both in terms of mobility and road safety. De-icing road salts, whilst reducing accidents and saving money, damage the natural environment. Little research has been directed towards understanding potential impacts of climate adaptation measures, in governmental sectors on cultural heritage.
That's interesting, Higgs. In this paper, the researchers use a semi-quantitative survey of 18th-century cast iron milestones in Sweden, to assess the potential impact of road salt, on the preservation of metal heritage objects. The paper discusses the degradation of cultural heritage in the context of winter road maintenance.
Right, Boson. The research looked at 37 cast iron milestones in Södermanland County in Sweden dating from the 1760s and 1770s. 7 are located along former road sections, while the other 30 are located along winter salted roads. The results show that greater degree of damage was recorded on the road-facing side of milestones on salted roads, than the side facing away. Milestones on unsalted roads do not exhibit any damage. If there is any damage to milestones on the unsalted roads, it is of similar in degree in the front and in the back.
Very important observation. To conclude, the results show that milestones on salted roads exhibited more damage on the front, irrespective of direction, and that milestones on unsalted roads showed similar damage on the front and back. In this pilot study, the researchers have demonstrated that climate change-related damage to cultural heritage may come from not only inaction, but also deliberate actions for adapting other sectors to climate change.
The results have wider implications for studying the secondary impacts of climate change on cultural heritage, both in terms of other monuments made of iron and metal objects in buried contexts such as graves. Conservation practice needs to be aware of all potential risks to cultural heritage, including those caused by the actions of other government agencies in attempting to mitigate the effects of climate change in other social contexts.
That is a very important point, Higgs. As the climate warms, road salt use will move north into areas where sites have been protected by contiguous winter snow cover. This will expose Arctic, subarctic cultural heritage, including Viking graves and Sami sites, to a new anthropogenic source of damage.